Hi, this is guidance for Strand 3 of Criterion E, in which you will develop an accurate design proposal of your commercial product in sufficient detail for a third party to manufacture it. This strand is a bit like Criterion C, and to meet the requirements of this strand, you will need to detail the design in sufficient detail for someone unfamiliar with the product to be able to manufacture it. These details should be presented in three separate elements: a series of technical drawings, assembly drawings, and a bill of materials. The technical drawings need to articulate the details of the product in order for it to be manufactured. Following the redesign of the product for commercial production, you will need to create technical drawings for any part that has been changed. This is important. For parts that have not changed from the prototype, you can include a reference to this rather than producing a new or replicate drawing of that part. Depending on the nature of the product that has been designed, the technical drawings may take a particular recognized form as appropriate. The technical drawings selected by you may include the following: product drawings, which are dimensional orthographic drawings that include details of all features. If you're doing textile or fashion, a dimensioned pattern including hemline, seam allowances, folds, placements of holes, fastening placement. If it's electronics, you should be having a circuit diagram and printed circuit board or PCB layout, identifying the components that will be included in the circuit and how they are connected. If a programmable intelligence computer is used, a flow diagram of the programming should also be included. If it's a mechanical drawing, you need a schematic of how the components interact. Ideally, individual parts will be detailed in the technical drawing with detail of how the parts are assembled, including an assembly drawing. It is very difficult to provide sufficient detail of a prototype in dimensional assembly or sub-assembly drawings without individual part drawings. When detailing features on a part, students should consistently give dimensions from a single edge or point. The position of the features should be clearly marked. Holes, circular features should be marked from their center. Square and rectangular linear features should be marked from a single edge. Other features may include clearances and chamfer, rounded, or beveled edges. Students may need to include a cutaway or section drawing to show internal details of parts. Technical drawings can be hand-drafted or generated through CAD software. Assembly drawings show how individual components fit together. Students should present an assembly drawing that includes all individual parts, standard components, and annotations where additional materials such as adhesive or finishes are used. Students may use one or a combination of the following: general assembly drawing, outline assembly drawings, diagrammatic assembly drawings, unit assembly or sub-assembly drawings, fitted assembly drawings, or exploded assembly drawings. A bill of material lists all the components needed to assemble the prototype and includes the material, the major dimensions, the number of components required, and an identifier or part number. Here's the example right here. For some processes, for example, injection molding, the student can include the amount of material measured by weight. For example, you might say ABS 26 grams in order to provide cost indications. The student may not include more than 10 words in each cell of the bill of materials. This is an example of a high-performing technical drawing. Both horizontal and vertical dimensions are sourced from a single point. There is sufficient detail to indicate the size and position of each feature. The center and size of the holes for the other half of the mold to slot into are positioned clearly, and details such as the desired threads are marked. Additional drawings provide insight into the three-dimensional detail of the mold. Few, if any, assumptions need to be made in order to make this part. This is an example of a high-performing assembly drawing and bill of materials. The assembly drawing shows all of the parts, and it is clear how they align to put together. Annotations provide further detail of how the parts are fixed together. The bill of materials is complete, including the overall maximum dimensions of each part. This is an example of a medium-performing technical drawing. Most details are included, although a third party would need to make some assumptions when making the mold. Not all the details are included. For example, the size of the threads at the top and the bottom of the mold and the size of the holes in each of the four corners of the mold are not specified. Some of the dimensions cascade from previous dimensions. When marking out, this can cause the carrying forward of an error. If all dimensions are made from the same origin, this ensures all features are marked from a single reference point and reduces the risk of errors. The drawing would benefit from additional guidelines being used to align the views. This is an example of a medium performing assembly drawing. The assembly drawing shows all of the parts, and it is clear how they align to be put together. Annotations provide further detail of how the parts are fixed together. However, the bill of materials is not complete and only identifies the materials for each part. The student would benefit from adding the overall dimensions and cost of the bill of materials to access the higher mark brands. This is an example of a low-performing technical drawing. The overall size of the mold and features are included. There are some dimensions of the feature, but these are not sufficient to make the mold as required. This is an example of a low-performing assembly drawing. The assembly drawing shows some of the parts and how they align, but there is no further detail included. A third party would have to assume how all of the parts are joined together. That is, the threaded parts and how the label wrap and holds the parts in position. There's also no labels included to identify each part, and there's no bill of materials.